Okay, so now that we're kind of done talking about stars and we've talked about some black holes. Now we want to kind of look a little bit further out, and we want to talk about galaxies. Okay, so a galaxy is a huge collection, and when I say huge, I mean huge, of gas, dust, and then hundreds of billions of stars. Okay, so we're talking these are huge. Our galaxy, as you know, is called the Milky Way, and it consists of 400 billion stars. Okay, the mass of the galaxy is 17 trillion times the mass of the sun. So this is huge. It has a diameter of 100,000 light years. So that's its diameter from one side to the other. And our galaxy has a spiral shape. Okay? Like all galaxies of that kind of spiral type, almost the entire mass is rotating. Okay? And it's rotating around kind of a thick central bulge, which is right in the middle. And that's really where all the older stars are, right? Basically at the center. So this thick kind of central bulge is in the middle, with kind of the oldest stars in the center, and then long streams of younger stars called arms circling around the outer central region. So this is Edwin Hubble's classification system. This is called Hubble's fork, or Hubble's tuning fork. And basically, you can kind of see that we have kind of this spiral shape, and there's, in each of these spiral shapes, there's this kind of central bulge. And we're going to talk more about these as we look at different types of galaxies. So the first is the spiral, which we've just mentioned. And a spiral, basically, they're relatively flat disks, and then the arms spiral out of a thick central region. Okay? And when we talk about A to C, we're talking about kind of like how open the arms are. So here is a spiral galaxy that's like the A type, and its arms are relatively closed. Here's B, the arms are a little bit more open, and here's C, the arms are very, very open. Okay? And you can kind of see the difference between these. And so there's two different types of spiral galaxies, round center and bar center. Okay? A round center is really just a spiral. A bar center is what we call a barred spiral. Okay? And the example of this is the Milky Way. So another type of galaxy exists. So there's actually two other kinds. The elliptical galaxies. The elliptical galaxies are kind of like football shaped, right? So they're ellipsoidal in shape. And they're rated 0 to 7 based on how elongated they are. So when we look at these, an elliptical galaxy that's 0 would be very, very round, so not as elliptical. And then we kind of go up the scale here until we get to E7, which is very, very round. Very, very round. And it is kind of like a squished football, almost. Okay, an example of an elliptical galaxy that some of you may have heard of is M87. And M87 is an elliptical galaxy, and at the center of M87 is a black hole called M87 star, and that is the black hole for which we took the picture. We took a picture of M87 star, and it's the first ever picture of a black hole that we've ever been able to produce. And I should say image rather than picture, because it's not like a picture that you take on your smartphone. It's an image that was developed from the Event Horizon telescope. Last type of galaxy that we have is the irregular galaxy. And these ones are kind of weird. They have neither a spiral nor an elliptical shape. They have almost no symmetry. And where we think they come from is that maybe maybe the reason that they're so distorted, that they don't have a shape, is because two galaxies have collided. And maybe that has kind of messed up the symmetry and kind of the spiral or elliptical shape. And so they've been distorted because they've had a collision with another galaxy. Okay. And a couple examples of these are the Magellanic Clouds. And we're going to talk about these kind of examples as we kind of come down and we talk about really who are our galaxy neighbors in kind of the universe city, who are kind of our galactic neighbors. The Magellanic Clouds, unfortunately, you'd have to go to Australia or somewhere in the southern hemisphere, maybe Chile, to see them because they're only visible in the southern hemisphere. And they're clearly visible with the naked eye, so you can kind of see this image here. So on a beautiful clear night, if you look up into the sky, you can see the large and the small Magellanic Clouds. They are 200,000 light years away. So close, but not obviously that's not attainable, but is in terms of the universe, those are fairly close. There's two galaxies actually, the large and the small Magellanic Cloud. That's what these things are, and both of these are irregular galaxies. So they're irregular in shape, as we saw up there. Andromeda is seen only in the northern hemisphere. It is visible with the naked eye. It kind of looks like a fuzzy, faint patch. Okay, it is, again, it's kind of close. It's like 2.2 million light years away. So this is far, 2.2 million light years away. It's a spiral galaxy that's very similar to our own, but it's smaller. It's a smaller galaxy than we are. And there's an image of Andromeda. And last, the Triangulum Galaxy. This is M33, that's its designation. It can be seen only in the northern hemisphere. It's hard to see with the naked eye, but through a telescope you'd be able to see it. This is 2.9 million light years away, so almost 3 million light years away. And this is a spiral galaxy that's even smaller than Andromeda. But these are our galactic neighbors. These are kind of the galaxies that are closest.